The overall goal of this procedure is to estimate the inertial properties of a below-knee prosthesis. This is accomplished by first measuring the period of oscillation with the prosthesis suspended within a cage. The second step is to use a reaction board technique to estimate the center of mass location for the combined prosthesis and cage system. Next, the prosthesis is removed from the cage, and the reaction board technique is used to estimate the center of mass location of just the cage. The final step is to measure the period of oscillation for the cage alone. Ultimately, this inertial measurement system was validated using known geometrical solids, such as a 4x4 wooden block. Results from these experiments are presented in Appendix A. Inertial measurements of the cage are subtracted from the measurements of the prosthesis and cage combined to provide estimates of the inertial properties of the prosthesis.
The main advantage of this technique over existing methods, like assuming inertial properties of the prosthetic side are similar to those of the intact side, is that the inertia of the prosthetic leg is more accurately represented in the biomechanical model of the person.
To begin, sit the amputee in a chair where the prosthetic leg can be comfortably lifted off the seat so that the subject can perform a series of knee flexion and extension actions. Next, identify the knee center of rotation, or COR, and place a small piece of tape at the COR. Then, measure the distance from the lip of the prosthesis to the knee COR. If the knee COR sits inferior to the lip of the prosthesis, this value should be recorded as a negative value. Next, determine the distance between the knee COR and the ankle COR. Then, remove the prosthesis and the underlying sleeve to take measurements of the residual limb using a flexible tape measure to estimate the inertial properties of the residual limb. Next, measure the proximal circumference of the residual limb, the largest circumference approximately 2 finger widths from the knee joint. Then, determine the distal circumference of the residual limb at the last bony prominence on the distal end. Next, measure the length of the residual limb, the distance from the fibular head to the most distal aspect of the residual limb. Remove the inner cage from the oscillation rack by removing the axle. Place the subject's liner and ply within the socket of the prosthesis. Then, securely position the prosthesis with the shoe still on within the inner oscillation cage, using a Velcro strap to secure the foot of the prosthesis on the distal plate of the cage. Next, reposition the inner cage within the oscillation rack by securing the axle. Align the suspending arm of the inner cage with the set screw, which will set the angle of oscillation to less than 5 degrees. To begin an oscillation trial, pull the inner cage back until it hits the set screw, and then move it forward until the space between the set screw and the inner cage is visible. Collect 3 oscillation trials with the prosthesis positioned in the inner cage, and record the average time for 1 complete cycle of oscillation for each trial. Prior to shifting the reaction board measurements, keep the prosthesis fixed in the rack and position the inner cage horizontally, resting it on the knife edges. Then, record the distance between the top adjustable plate and the fixed cross member at the top of the inner cage, using digital calipers and a flexible measuring tape. Next, measure the distance between the bottom adjustable plate and the fixed cross member at the top of the inner cage, and determine the distance between the bottom adjustable plate and the fixed cross member at the bottom of the inner cage. Then, measure the distance between the 2 knife edges. After tearing the scale to 0, position the rack and prosthetic limb in the reaction board assembly. Then, place one end of the inner cage over the scale, and position the knife edge at the bottom of the inner cage so that it is level and there is no tension between the two knife edges. Lift the scale end several times and place it back down on the scale. Record the value once a consistent reading from the scale is achieved. Next, remove the prosthesis from the inner cage and record the reaction board reading for just the cage. Remove the shoe from the prosthetic limb and measure the mass of the shoe. Then obtain the mass of the prosthesis without the shoe. Next, measure the distance between the COR of the ankle and the plantar surface of the foot. Then, determine the length of the prosthetic foot without the shoe. Place the shoe back on the prosthesis and measure the distance from the ankle COR to the sole of the shoe and the length of the foot with the shoe on. Then, reposition the inner cage within the oscillation rack, making sure that the black corner with reflective tape is closest to the photocell. Secure the axis and make sure the suspending arm of the inner cage aligns with the set screw. Finally, collect 10 oscillation trials, recording only the first oscillation period of each trial. See Appendix A for an explanation of why only the first period of oscillation is recorded when the cage is empty. Inertial properties of the prosthetic side were significantly lower than the inertial properties of the intact leg. The mass of the prosthetic side was 39% less, the moment of inertia was 52% less, and the center of mass was 24% closer to the knee than intact estimates. Joint reaction forces of the ankle, knee, and hip were determined in the anterior, posterior, and vertical directions. The stance phase begins at 0% of the gait cycle and ends at approximately 60% of the gait cycle. Swing continues until the next foot contact of the same leg at 100%. The following results were obtained when analyzing joint moments about a transverse axis through the ankle, knee, and hip. Joint kinetic profiles of the prosthetic side during swing more closely resembled those of an intact limb when inertial properties of an intact limb were used to model the prosthetic side.
Once mastered, this technique can be performed within 30 minutes, if done properly.